Hey everyone, I wanted to go through this tutorial with you all. I'm actually going to be using it as a skeleton, and I'm going to add more information on top of it just to get more meat on those bones to further develop our intuition of how it's really working under the hood. Okay, now the first thing we're going to be discussing is this photon cloud, which is this really, I'm not going to say necessarily elegant, but it's definitely simple. And it's simple because all of the harshness of developing our own server, maintaining it, that's all abstracted away from us because the Photon Cloud does that job. So, for example, instead of purchasing our own virtual private server somewhere and then building the server application and making sure that's always running and making sure that's connecting to our clients, that's all done for us. We just need to concentrate on the client side, which is, the game itself. So that's really convenient. And to do so, we need to download a package and import it into Unity. So let's start up with that. Let's make our way to the Unity Asset Store. And a quick search for Photon isn't all that convenient because we get here Photon 2. Yes, we do want Photon 2 and not this Photon Classic because Classic is no longer supported with newer versions of Unity according to Photon themselves. But this Plus version, 95 bucks, no way. Where's the free version? It's like not even easy to find, not even on the first page. So Photon 2 free, that's a better search. All right, here we go, Photon 2 free. What are the differences between paying for the service and not paying for it? Well, you get better servers the more you pay. So better bandwidth, better specs, more RAM. Anyways, we don't really need anything really powerful. So the free version is going to be more than enough for us. Now here I have opened in Unity because I've already added it to my personal collection attached to my account. But if you haven't, just click here. It will add it to your collection. Now you want to make sure that you are logged into the Unity Asset Store, of course. With the same account, you're going to be logging into the Unity Hub. So here I have my account KR. And if I open up Unity Hub, here I'm also logged into that account. Now I'm going to download a copy of that package locally on my computer and import it into different Unity projects, such as this new one. So Window, Package Manager, here we select My Assets, then PUN2 Free. You might need to click on Download here. Once that's done, you click on Import. Now a bunch of files here are just for demo purposes, but I'm just going to keep everything and not filter to keep things simple. So click on Import, and then we wait a few seconds, so I'll see you then. Once you're done importing the package, you get this PUN wizard window. And the first thing it's demanding is an app ID or email. This is going to be regarding your Photon account. Even for the free version, we need to create a Photon account. So we just go on their website, sign in, don't have an account, create one, and then we go through the typical account creation process. So I'll see you in a couple of seconds. Once you have successfully created a new account on Photon, navigate to your dashboard, then create a new app. This will create a new web app that we can connect through. So Photon type, let's select Photon PUN, application name, call it test for now, and we can keep the other fields empty. What's really important here is that we generated this app ID. Now, if you're familiar with web apps, you are probably familiar with the concept of app IDs. So we want to copy this ID. Now, this ID is going to be pasted into one of the fields for our setup in Unity. Now, I've lost my little window that we had before here about inputting an app ID, but no problem. I can just go on Window, Photon Unity Network, PUN Wizard. Then I have setup project, and now I'm going to paste in that ID, click on setup project, and we can notice that a new asset was created. So we have this new file called Photon server setting.asset. It's in this directory. And we can see that if I expand this, app ID PUN, that's the ID. So this is actually what the wizard was doing. It was just creating this object and copy pasting this value into this field. Of course, you can change this manually if you want, through the inspector or even just through this file itself. Let's start off by connecting to our web app, also called the server in this tutorial. Now, we see that the tutorial contains some code. I want to start even simpler than this. You might be rolling your eyes by me saying that, but the first thing I want us to successfully do is connect to that web app and nothing else. Well, actually, I also want us to see what happens if we cannot connect to the web app. So let's test these two cases, connection successful and connection not successful, and see what the results are. This script is all we need for our quick experiment. Notice how it's still deriving from mono behavior. This will be important later on because we won't always be deriving by mono behavior. We might be doing something different. Also notice here we are using photon.pun. So getting that library, which allows us to use this static function from the Photon network library called connect using settings. And these settings are that object that we discussed about, the PUN settings. Okay, so this is a public void connect function. I made it public just because, well, we might want to connect to the server not only directly through, let's say, a Unity event like await or start, but we might want to call it from a different class. And here we have our start that will, well, once we start the script, we want to start actually doing something. And one of those things is connecting to the network. Now, very simple script. So I'm just going to save this and let's test it out. Okay, so I have my script here. I really should be organizing my stuff by putting it in the scripts folder, but oh well. Now I've got this other game object here called launcher. And it has my test PUN code. I'm just going to go back and make sure that I have my app ID. So a quick way of doing that is PUN wizard, locate Photon server settings, because I have a hard time finding it sometimes. So I have my object here. Let's take a look. Okay, I have my PUN app ID set up. So I start the game. So no errors in the console. Everything seems fine. We have this warning, and this warning, it does not explicitly say it, but we can only get it if we successfully connect it. So that's great. Now, I'm just going to remove the last character here. So I have an invalid app ID. Start it up once more. Okay, and here we are. App ID is unknown on the cloud server. Perfect. Let's try and understand how the connection process actually works behind the scenes. So I've pulled up some documentation from Photon, and we can see in this diagram, we start off at the client point. This is us. All the players are clients, and the servers aren't managed explicitly by us. So we don't need to work on a VPS or something like that and just start up the processes and manage all the servers ourselves. It's taken care of by the Photon cloud. So that's one of the strong points of this entire system, right? Now, the first thing that happens is that we connect to a name server. And this is the same process no matter where you are in the world, in the sense that we're all connecting to the same name server. So it's just one IP address that everybody connects to. Now, the domain name associated to this IP address is actually ns.exitgames.com, ns for name server, and Exit Games is the company behind Photon, if I'm not mistaken. So if I'm in Canada and you're in Korea, well, we start by connecting to the same IP address. And on the name server, which is actually located in San Francisco, because I believe Exit Games are also located in San Francisco, it will take the app ID that we give it and try and connect it to our app, and then it will see some information concerning our app. So we'll get into those kind of properties and informations about our app later on, but one of them is what regions are allowed. So let's say I say that my game works for Canada, US, and Japan. I will have, let's say, 3 possible master servers. Now, you will end up pinging one of these master servers. And let's say you want to select the best server for you for the least amount of latency. Well, it's a simple algorithm. You can just ping each one of these servers like 5 times, take the average, of each and see which average is the lowest. So the one with the lowest ping on average will be the best option and just connect you there. So this name server can channel you to the best possible master server. And then we have step 3, where you actually enter a real game server, which is created by a player, for example. So a player can just start up a server. But again, this server will not be located exactly locally on somebody's machine, on a player's machine. It will still be in the cloud, right? All of this is in the Photon cloud. So there's just a bunch of servers. Now, once again, everybody connects to the same name server. Then you will typically want to select the best regional server for you using the simple pinging check. And then you'll get connected. So you'll join an actual game server, which will have a different IP than any of these master servers or the name server. And if you want to create a new server instead of joining one, that is still handled all on the cloud. Okay, so that's a brief overview. Now we're going to take a deeper look into this, but a bit more practically by seeing some values in Unity. I'm back to where we previously were. Now recall that this ID is incorrect because I should have a D at the end, but I removed it. But one key thing I'm going to change here, network logging, I'm going to go to all. Okay, and PUN logging, I'm going to say full. So I'm going to get a bunch of information now in the console that will really help us understand this entire connection process that I've just described. Okay, so this makes sense to have something in red here because once again, the app ID isn't correct, but there's still so many other things going on even if the app ID is not correct. For example, we start up here, okay, we create an instance of socket UDP async. What information can we get from this? Well, it seems like our connection is using the UDP protocol and not TCP. So that's already interesting to know. Why UDP over TCP? I really don't want to get into that, but games will oftentimes use UDP just because it's a bit faster since there's less checking. So it's not as safe in terms of dropping data, but it's quicker, and in games we really want speed. This type is provided by the Photon library, and I think at the end of the day, it's actually implemented with a C#, or I should say a .NET socket, which in turn is implemented somehow natively in C or something. Anyways, that's not really important. This is all going to get compiled down on release to C++ anyways, so. But it's just interesting to know that this is working through sockets, and UDP sockets to be more precise. It's not like HTTP requests, because that would be excruciating and very slow. Okay. It's also not a web socket, just a simple socket. Okay, enough about that. So we see here, okay, iPhotonSocket.connect to the name server. Here we are, nsexitgames.com, and the port is 5058, so that's the same thing for everybody. And then we have some more information here. Okay, that's not too interesting. Oh, connected to name server. All right. Now get region failed. Okay, so as I said, once we connect to the name server, that server is going to try and connect to our app through the app ID and get all the regions that we're allowed to connect to. And now it can't because the app ID is unknown. Okay. So even if the app ID is incorrect, we can still connect to the name server because that's just like a hard-coded value, this nsexitgames.com 5058 somewhere, and their servers are always running. So there's no reason why this should not connect. But then we can obviously notice that it can't really fetch information about our specific app since the app ID is incorrect. So then we get a will not ping, return code, and disconnect. Okay, so I've updated my app ID, I fixed it. But now before testing, we need to discuss this whitelist. So there is a region whitelist, and by default it is empty. That means we can connect to any region, any master server. Actually, I should probably discuss the terminology here. Now, whitelist and blacklist aren't really in favor anymore for some pretty good reasons in my opinion, but I don't want to be too political right now, so I will continue using the word whitelist just because Photon has not updated their terminology yet. And, well, if you're looking at the documentation, you're kind of forced to use these words. Anyways, if we want to, say, allow only 2 regions, let's say Japan and China for some reason. Well, we have to go in our whitelist, and we don't remove items. We add what we want to be available. So it's kind of interesting, I guess you could say, because when it's empty, it's all regions. But at the moment you put one item in that list, then that becomes the only region that's available. Once you add 2 items, then those become the only 2 available regions, and so on and so forth. How do we actually edit it? Well, we can click here on Edit Whitelist. It should bring us to our dashboard, actually. Now I'm still logged in, so bringing me to my dashboard online. If you want to do it without Unity, you can just go into your project here, like Test, Manage, go all the way down and Region Whitelist. Okay, so Edit Whitelist, and now we can start adding regions. So for fun, let's just add Korea and click Save. Okay, so why was it KR? That's not for Kyle Ross. I'm not that egocentric. It's because it's a token for the South Korea region. So KR for Korea. And we can notice here that all the game servers that are going to be hosted in the South Korea region are actually from this data center in Seoul. Now, what's really interesting for us at Concordia is that Photon actually has a Canada East region where all the game servers are going to be hosted in Montreal. So we can expect some pretty low latency for our tests, which is quite interesting. Okay, so for this quick section, just imagine that Radiohead's Creeper is playing in the background, because we're going to do some geolocation funny business right here, just to confirm everything. So I'm going to take that IP address that I saw in the Unity terminal and put it into this geolocation tool, which is called iplocation.net, and really confirm that, yep, this IP address is in Seoul. Here I have latitude and longitude values, and this is as far as we're going to go down the Creeper hole. Okay, now back in the inspector, I've stopped the test, but we can notice that this value changed here. Best region is KR, which is obvious since it's our only region. Now, I've done this test one more time, which is why it says 182 instead of 181, so don't mind that. And, well, this was fun for our test, but let's not use Korea, unless you are in South Korea, and if you are, please bring me back some food. But for all the rest of us, we're going to switch from KR here just to nothing. Okay, and I'm going to start this off one more time. So let's see here, PUN got region list. And this time, okay, it's going to ping a few regions. We can see that's going to ping CAE. It's also going to end up pinging EU. They're not all displayed here, but the best one that was found was CAE with 17 milliseconds. Now, once again, I'm on some bad Wi-Fi here. You can probably expect something a bit better, maybe even like 9 or 10 milliseconds if you are in Montreal. Okay, so this is great, and we can see that the best region has now changed to Canada East. This video is not sponsored by NordVPN or ExpressVPN, but if you actually do have a VPN, try changing your region and seeing what results you get out of this. Let's carry on. Let's start by this concept of joining a room. To reiterate, our client has successfully connected to a name server, then to a master server, which is going to be CAE in my case. Now, on this master server, we're going to have multiple game servers where things actually happen in terms of gameplay. So this join random room function is just delegating to this Photon network.join random room. Think of a room as one of these game servers for now. It's not exactly the same thing, but for simplicity, let's say it is. So let's say that there are maybe 3 rooms happening right now on the CAE master server, and we want to join a random one. So this is a really basic way of doing matchmaking, for example. Of course, if no game server exists, well, what do we expect to happen? Let's take a look. So I am actually calling this join random room function after I've successfully connected to the name server and a master server, as we just saw. So let's take a look in practice. And already some red. Okay, here we go. Client is on name server. Good, but not ready for operation. That's because, well, no actual game server, no rooms have been created. So this makes a lot of sense. if I can't join a room, I'll create my own. Now line 21 does just that. So it's again using the Photon library. And this method takes one parameter, which is the room name. Now what's interesting is that if we, I'm just waiting for my tooltip to come up. Okay, here it is. We can see room name. So creates a new room, unique name of the room to create. That's what we pass in as an argument. If you give it null or an empty string, the name is going to be generated by the server. So that's interesting. Now, obviously, the ideal situation here is not to have something hard-coded or necessarily generated by the server. We will have a UI that will allow the user that wants to create a room to type in the name room. What are these other parameters, however? We have this room options, type lobby, and expected users. Let's not discuss them right now. They're all used in some fashion, but they have default values, meaning that I don't need to explicitly give arguments when I'm calling the function for those three parameters. In my start, once again, I am connecting, then creating a room. So I feel pretty confident. Let's try this out. But of course, every time I say I'm confident about something, you should be wary because there's always a catch. And here is that catch. Now we can see, okay, you are connecting to the name server. Nice. But then you try and create a room. So this is at 6 p.m. 41 seconds. You're trying to create the room. But are we even connected to a master server? Are we even connected to a region yet? Not really. Because that's happening down here. So this is 43 seconds and this is at 41 seconds. So we have this sort of, I guess you could call it race condition. I'm not so sure how this is all implemented. Like there's probably a thread for the connection. That's what I expect. So when we create, when we call this connect using settings, I think this is starting up a thread to do that connection. And it's a non-blocking thread, right? So this allows me to call the next function, which was create room, but my connection isn't fully warmed up. It's not fully complete. So I have to wait for that to complete before I can actually, well, try and create a room. Because if I'm not connected to a region, I can't instantiate a room, well, in my desired region. Okay, so, well, let's try and figure that out. Let's think of a few solutions for this problem. Now we could go full on nuclear and say, hey, let's just sleep the main thread. And that sounds as dirty as using gotos in our code in the sense that, yeah, sleeps and gotos, we need them sometimes. They exist for appropriate reasons, but this is not one of those cases. This is not one of those reasons because we have this fantastic like interface here through PON callbacks. Now, we have a bunch of interfaces actually. So we can like bind to certain events declared in these interfaces. For example, let's check out this iConnection callbacks interface. And we can see here that it has this onConnected method, for example, or onConnected to master. That means that if we implement iConnection callbacks, we can define onConnected to master. Once again, this is all in an interface in C#, so these are abstract. So they don't have any definition, they're just declared in an interface. So we can define it, or I guess you could say override, even though there's no default implementation. And we know that this is going to get called somewhere. We don't know exactly when or how, but we know it's going to get called. So we just say what we want to do when it's going to be, well, called. This is similar to our Unity event functions like awake, update, start. We don't know exactly who's calling them, but we know what we want to do when they do get called. For example, we could do a debug.log here on onConnected to master that will write in the terminal successfully connected to master or something like that. Or even more appropriately for our case here, once we're connected to the master, then we can create a room, or then we can join a room. So these interfaces are quite nice because they're really simple to use and they're not all that different from what we're used to with Unity events. And there's a bunch of these categories. Now, of course, if you want to implement iConnections callbacks, well, then you have to implement all these other ones. So even if you only want to use onConnected to master, you still need to add declaration and definition for all these other methods. I mean, they could be empty, which is fine, meaning that on disconnected, when that, let's say, event happens, well, you don't really do anything. But there's a downside to that, just because our class will probably get quickly filled up with a bunch of declarations with empty definitions for all these methods we don't really want. So again, this is an interface, meaning that we have to define them in a concrete class, such as the class we're working on now. But we can't keep them empty if we want. But we still have to declare them, and they're going to take some space in our code in terms of lines. So they knew about this potential problem, right? And it's described here somewhere. Okay, so this is a very secure way to make sure a class compiles to all the interface, but forces the developer to implement all the interface declarations. Once again, they have to be declared, but they also need to be defined. That's what they mean by implement, even if their implementation is empty. Most good IDEs will make this task very easy. However, the script could end up with lots of methods that may do nothing, yet all methods must be implemented for Unity compiler to be happy. So this is really when your script is going to make heavy use of all PUN features. So PUN features are those events in these different interfaces. Here's a solution to that. Extending model behavior PUN callbacks. So we can use a different flavor of model behavior called model behavior PUN callbacks, which basically has all of the events and all of these interfaces already baked into the class. So they're all there, meaning that once we derive from it, we don't need to implement all of them. So it makes our, let's say, higher level class, like this launcher class that's deriving from model behavior PUN callbacks, a bit lighter. Maybe a concrete example will really express what I'm trying to say here. So let's take a look at that. Have a look at this model behavior PUN callbacks class. First of all, we can see that it's deriving from model behavior PUN, which in turn here derives from model behavior. So we can just think of it as model behavior pretty much with extra steps. But here's the interesting part. All of those interfaces are implemented in this model behavior PUN callbacks class. So notice we have onConnected, onLeftRoom, onConnect masters here somewhere, onConnected to master, there it is. And notice they're all empty, but they're virtual. So they're all implemented here. They don't do anything, and they're virtual, meaning that we can override them. So I can go back here in this test PUN that we're developing, inherit from model behavior PUN callbacks, and I don't have to add all of those things. Like if, let's say I want to use onConnected to master, but not onConnected, well, all I need to do is simply public override, and now I can override onConnected to master, and then do whatever I want. Now in the documentation, it does mention not to call the base. So I don't want to call the base implementation here somewhere onConnected to master, because, well, there's nothing really happening here. So let's just avoid that extra call. I mean, it might get inlined at the end of the day. The compiler might optimize this to not even call it since it's empty, but let's not add extra lines of code for no apparent reason. So how about let's do a debug.log. I'm going to write connected to master. Okay. I'm not going to connect or create a room right now. I just want to really test out this onConnected to master functionality. Here it is. Okay, finally. Now, it took quite a while, but we definitely see that it happened after everything else. So this was at 1909, the timestamp. When we started the connection, it was at 8 seconds. Okay, so 8 and then at 9, so it took pretty much an entire second. I've updated my code here to fundamentally do the same thing as section 1 in the tutorial. However, I'm adding a bit more information to make things really explicit. So let's go over all the steps. I start by trying to connect. So here, when I try to connect, I have a message connecting to name server, and then I actually call the logic for my connection. And from this, a bunch of events are going to be launched or triggered. For example, on connected, once I am connected to the name server, I'm going to show a message here, connected to name server. Now, yeah, I could write this function all in one line, as I typically do, actually, like this. But, oh well, I'm just keeping it in this syntax for now because I might want to add more stuff later on. Anyways, so unconnected, I'm going to display this message in the terminal. And afterwards, once we're connected to the name server, we know that it's going to attempt to connect to the master, to the region. So once that is done, we're going to debug.log, connected to master. And then we're going to try to join a random room. Now, if we can successfully join a random room, on join room here, it's going to be triggered and we get this message, successfully joined a room. If we cannot join a room, on join random room failed. So there's on join room failed and on join random failed. That's when we try to join a random room, obviously. So we get a return code and a message. I'm going to print out the return code here. Return code is this and the message is this. Then I'm going to say, could not join a random room, attempting to create a room instead. So if I can't join one, I'm going to create one. So create room, and we have then our function as before, but now we're going to say attempting to create a room. Then we start creating this room, and this is going to trigger on created room if we successfully created a room. So we can actually really follow everything going on here thanks to these debug messages. Now this code here, I mean, this is already quite a big class for not all that much. There are ways to refactor this, maybe make this a bit smaller, but I think this makes things quite clear at the same time. Let's test it out. Actually, here in network logging, I'm going to put it back to error and PUN logging errors only. I don't want all that extra information now that I'm debugging, debug.logging a bunch of stuff myself. So here we see, let's start connecting to the name server, then we are connected to the name server, then we are connected to the master server, we attempt to join a room, here we get return code, and message no match found, could not join a random room, attempting to create a room instead, attempting to create a room, successfully created a room, and then we join that new room that just got created. There's one glaring issue in our workflow right now. We can create a new room, but we can't join an existing room. That's because I only have one instance of my application running, and it's running through my editor. If I really want to test somebody joining an existing room, that means I need to build my program and run the application twice. The first instance will create the room and the second one will join it. Now, that's not complicated, it's not complex, but it's a pain to always have to build every test instead of testing it directly in the inspector, in the editor here. Now, I'm going to take 0 credit for this, but as you might have seen in our general channel on Discord, Daniel Rinaldi had the perfect solution to this by introducing us to parallel sync. So I have it actually already here installed in my project, and I'm going to show you all how to do the same. A quick Google search for parallel sync will bring us to this first GitHub page, where you can actually clone the repository and build the Unity package yourself. But you might be, let's say, too busy for that, so you can go down here and just get a pre-built one. 1.4.2 is what I'm currently using, and you can download the Unity package right here for yourself. So don't mind the source code if you don't want to build it yourself. Don't mind cloning it with Git if you don't want to build it yourself. Just take this and import it into your Unity projects. The simplest way to import a Unity package that's not through the Unity registry or the asset store is simply to go, let's say here in my assets, right click, import package, custom package, and I'm going to go find that, which is here. And once again, we have some demo code, I believe. I'm just going to import everything. Okay. Now let's notice this new folder, parallel sync, and this new section above here, parallel sync. If you see this, the operation was successful. Let's try this out. Parallel sync, clones manager. If I want to test it out with 2 players, I create 1 clone. If I want more players, I could potentially create another clone by clicking here, add new clone. And now I'm going to close this. And let's take a look. So here's my file system. Photon Lab is my original, and create Photon Lab clone 0. If I had another clone, it would be clone 1 and so forth. So this is interesting because all it's really doing is cloning our project. Now, of course, if your project is huge, this could potentially lead to a whole lot of disk space usage, but let's say that it's fine for our purposes. And how do I actually launch, however? Well, I could just add the clone to Unity Hub and then open up another Unity editor and have both of my editors open up side by side, or I can just go back here in my clones manager and open a new editor just to simplify things. If I would have clicked on delete, we would have seen this clone 0 disappear. So it just really affects our disk. It's just reading and writing a bunch of files to this clones manager ultimately. Okay, so I have it open here. I think I can close this for now. And let's run a test. So on the left, we should create the room. Created a room, and on the right, well, on the right, I need to open up my scene. So scenes launcher, okay, there we go. I could change the default scene here, but I just forgotten to do it, so. Okay, here we are. Now, connected to master, attempting to join a room, successfully joined a room. All right, so things are functioning as we hoped. But you might be wondering, well, what if I change the code, right? If I change the code that's in the first original project, it's not going to change the files in the second one, right? Well, obviously they've thought of that because otherwise this tool would not be very useful. So for example, if I open up my code here, and let's say that when I join a room, it's going to add an extra word here to be really obnoxious. Okay, and let's test it out. Now remember, this script is in my original project, not in the clone project. Oops, let me just stop this for a second. There we go, okay. So I'm going to start this one. Here, okay, successfully joined a room, yeah. And now let's try on the right. Successfully joined a room, yeah. Okay, so it works. That means that if we modify, even after cloning, an original file, there's a watcher somewhere that's monitoring all of our files and updating the cloned versions. So it's pretty seamless to use. And it might seem a bit like brute force, like such a simple solution, but sometimes simple is good. I think now's a good time for a break. So let's call this part 1 of the series, where we went over basic setup, basic understanding of the cloud model. We've got our tool for testing, which is parallel sync, and we also got some understanding of the room system and all the callbacks we can call within Unity scripts.